Well, good morning to everyone, and I'll just introduce myself quickly. I'm a program officer with the Secretariat of the Basel, Rotterdam and Stockholm Conventions. I've worked on the issue of ship recycling for, many years, at least 10 years. First with the UK government and later with, it's one of my responsibilities under the Basel Secretariat. So very pleased to see those who are on the attendance list today. We did have a lot more registrations, but fortunately we have another webinar on Thursday afternoon, so we hope we can capture those people and have them join on Thursday. So today we're wishing to give some information on a feasibility study that was completed earlier in the year on alternatives to the beaching method of ship recycling. Now this study has been available on our website since April. As many of you know, we've had quite a busy year with our COPs and then the summer period, so this is really the earliest period that we've been able to present via a webinar to interested stakeholders. So, as Dan has said, I'll start off with a brief introduction of to the feasibility study, just the background, the reasons why the Basel Secretariat commissioned this work. I won't take much of your time because Sven Overgaard, our consultant from Lighthouse, has a very interesting presentation to follow. So to give some background to the study, the Basel Secretariat, way back in 2007, established the Global Program for Sustainable Ship Recycling. Now, this was really to bring concerned stakeholders together to ensure coordinated action with regard to improving standards in global ship recycling. Now, as I'm sure you're aware, there are many different organizations that participate or contribute to this industry and who are also working on rules and regulations with regard to the industry. Essentially, this global program was an attempt to bring all of those stakeholders together. And we have been successful on a number of occasions bringing organizations such as the International Maritime Organization and the International Labour Organization together to ensure combined action. So we've undertaken a number of activities under this program. I'll only mention today 2 activities. The rest are available on the Basel Convention website under the ship dismantling section. Now, the European Commission, as we know, has taken quite a keen interest in this issue, also developing regulations on ship recycling. We've received 2 grants through the Commission to work on ship recycling. The first grant, I earlier mentioned Roy Watkinson. He undertook the first study under this grant, which was a case study looking at what is compliance according to the Basel and Hong Kong conventions. So this means particularly for a beaching facility, what could be deemed as a compliant facility, first of all, and how can these facilities be assisted in reaching compliance. We wanted to look at this similar to as we'd done in the Basel guidelines 10 years prior, in a short, medium and long-term stepwise approach. So the case study determines what compliance is according to these 2 major conventions and then prescribes actions, particularly for facilities employing the beaching method. Now, the second study, the feasibility study, which we're here to talk about today, really is the second part of the grant from the European Commission. This is to look further into the future. The Basel Secretariat's tried to take quite a pragmatic approach with regard to ship recycling and to its capacity building work, but recognizes that really we would like to encourage a move away from the beaching method in the medium to longer term. Therefore, this feasibility study looks at alternatives to the beaching method of ship recycling. And the main requirements of the consultant to undertake this work was to look at what are the alternatives. Really, the main alternatives we're aware of are pier braking and slipway braking. Of course, dry docking is also an option. So what are these alternatives? Where could these alternative types of operations be established, and what would be the cost? I should mention that it's not only to establish new facilities. As you can imagine, this would require quite a lot of capital investment to begin with, but also looking at already existing facilities who would need to upgrade to compliance under the conventions. But when I say already existing facilities, I'm really referring to pier and slipway facilities. We tendered for this contract last year, and the contract was awarded to Lighthouse, which is an environmental consultancy working mainly in the maritime sector. So without further ado, I'd like to pass over to my colleague Sven Overgaard, who will provide you the results of the study. Thank you.
Good morning, everyone, and thank you, Susan, for the kind introduction. My name is Sven Overgaard, and I'm from Lighthouse, as mentioned. And I will just briefly introduce our company. Apart from ship recycling, we also work with ballast water issues and air emissions and environmental issues in the Arctic and waste and oil rigs. Some of our selected references for ship recycling is we led the World Bank study in 2010 on the shipbreaking industry in Bangladesh and Pakistan. We also recently did a study for the Dutch and German development banks, the FMO and DEG, on global best practices and applicability in ship recycling in Bangladesh. Also done a project for the Danish Environmental Protection Agency, where we assessed yachts in Europe, Turkey, and China, and of course a number of IHMs and green passports. I reckon that most of you I know about the ship recycle method, but I'll just briefly introduce the concept of ship recycling before I go into the result from the feasibility study. And basically, we have 4 methods of ship recycling. We have pier braking, which is a top-down dismantling process. This is mainly done in China and Western countries. We have the landing, the slipway, which is where the ship is sailed onto a hard landing. And it's also a top-down dismantling process. This is the method we see applied in Turkey. As Susan mentioned, we have the dry dock, which basically is you sail it into a dry dock, you close the ports, and you have a totally confined area with minimal risk to the environment. And of course, the beaching, which is applied in India and Bangladesh and Pakistan. The ship is sailed onto a shore, and they use the tidal guard to sail it onto the shore, and then you dismantle it from the stern to the bow. The top 5 recycling nations constitute 98% of the world totals in 2011, and these comprise India, China, Bangladesh, Pakistan, and Turkey. So that's the main beaching nations, and China has a pier braking and Turkey has landing. I just included this. I know this is old data, but just to give you an idea that the scrap volumes in the future will continue to rise, and we foresee that it's somewhere between 10 million and 20 million gross tonnage per year. I'll just skip further here. The main reasons is obviously there's key impacts associated with the current methods of ship recycling. And we see occupational health and safety issues, worker fatalities, injuries, a lot of health issues related to exposure to hazardous materials. And we also see environmental degradation of the surroundings, contamination by hazardous materials. As you can see from the bottom picture here, that's basically a hole dug in the sand where all the residual oil from the shipbreaking is put into, all that oil that is not resold. You see your worker on your left, which has no breathing apparatus, and a favorite of mine is the picture on the right, where you see about 10, 15 workers walking barefoot with a large plate of steel. And in the background, you can see the lifting machine with a magnet that does exactly the same work. And these two are obviously not very fond of each other. Some of the main regulatory drivers for greening of the industry is, as mentioned, the Hong Kong International Convention for the Safe and Environmentally Sound Recycling of Ships. We also have a host of multilateral agreements. These comprise specific the Basel Convention and the Ban Amendment, but also the Stockholm Convention and the Montreal Protocol, to mention a few. And of course also a host of ILO agreements on workers' rights and occupational safety and health conditions. Well, to get to the crux of the matter here, the feasibility study was to identify cost-effective alternatives to the beaching method of ship recycling. And we looked at two scenarios: the upgrade of existing facilities and establishment of new facilities. And the study approach was, I can see the picture here is stretched in a funny way. I can see that the study approach was basically that first we identified the components of environmentally sound management. What does a model facility need to have to be environmentally sound? Secondly, we assessed the current applied methodologies on gear braking and slipway, and established a baseline of how many components did they actually apply at this point in time, and what were the upgrade requirements to reach the level of the environmentally sound model facility. Then we estimated the cost of the upgrade and did a sensitivity analysis on the key investments. We also looked into how that would look in a time scale, in like an incremental implementation schedule for different components, and try to identify the feasible locations for model facilities. During the course of this study, we also had consultation with stakeholders and did a field trip to China to visit the environmentally sound shipbreaking yards. So, for the components of environmentally sound management, we basically used the Hong Kong Convention technical guidelines, also called the Facility Guideline, and the Basel Convention's technical guideline, and divided the components into four key areas. These are the pre-cutting phase, where documentation and identification of hazardous materials are. There's a cutting phase, where all the equipment for the dismantling activities, and yard facilities, and lastly, quality assurance and procedures. For the first area, the documentation and identification of hazardous materials, this basically comprises the identification of hazardous materials on board the ship. If there is not an inventory of hazardous materials, it could be what are the procedures to identify the hazardous materials. It's a labeling, it's the creation of the inventory. The cutting phase for the equipment and dismantling activities is all the equipment that is needed to ensure proper handling of hazardous materials, and equipment to secure the workers working on dismantling, It's all the heavy machinery and light machinery to actually do the dismantling. The yard infrastructure and equipment comprise, for instance, containment installations. It's the impermeable flooring for the hazardous materials handling areas. It's and storage facilities. It's bill response equipment and so forth. For the quality assurance and procedures, we looked at the cost of ISO certification plans, and that could be the ship facility management plan, it could be the specific ship recycling plan, and it comprises also the training personnel and training schedules and so forth. Based on all the identified components which were cost efficient, we developed a model facility, and model facility basically is comprised of all the components with differentiating levels, differentiating number of components. And then we assess the level of the currently applied equipment and procedures and available infrastructure that was already applied in the pier breaking and slipway facilities around the world. We did that to be able to assess the operating to reach the level of a model facility. Based on that, we did 4 baseline facilities, and these were, the first was an existing non-compliant pier breaking facility. Second was an existing non-compliant slipway facility. And then we have 2 baseline facilities which has no prior activity. There's a basic establishment of the facility and the harbor area to establish a landing facility.
Sven, can you hear me? Sven?
Yes.
Sven, can you hear me? You're experiencing a sound issue. Your voice on that last slide has been cutting quite often, and we haven't understood the text you've read out.
Sure. What's the sound like now?
Now it's okay, but sometimes the sound is just cutting. There are some empty spaces between your words, but while you're speaking, the system is cutting down.
Is it the system that shut down, or is it my microphone, do you think? I can see that.
Now you're speaking, I can hear you perfectly.
Okay.
But maybe speak a bit slower so that if it comes back, I'll let you know.
Okay. Yes, please. How far back should I go?
Just this slide.
Just one slide?
Yeah, just the beginning of this slide.
Just the beginning of this slide. Okay.
Thank you.
You're welcome. I'm sorry. I hope you've heard all the key information here. Basically, the 4 baseline facilities that we developed, comprise an existing non-compliant pier breaking facility, an existing non-compliant slipway facility, and two scenarios where there's been no prior dismantling activity, and one was a basic pier to be used for a pier breaking facility, and a basic harbor area to be used for a slipway landing facility. And the last 2 scenarios is establishment from scratch. There is no prior operation of dismantling in these. I hope you can still hear me. So of course there's some assumptions associated with these baseline facilities, and in general we assume that all the electrical infrastructure was available, basic installations, electricity, water, etc. Got access roads to the yard area. There's crucial waste treatment facilities and disposal facilities in form of, for instance, landfills. There are also a host of like specific facility assumptions, but these are depending on what site or type of site we're looking at. Is it an existing pier breaking facility that has certain assumptions associated with it, or a slipway, or if it's establishment from scratch for pier breaking or slipway. And these assumptions associated with equipment, personal protection equipment, infrastructure, etc., at the level of applied equipment. We looked also at the unit price in order to be able to estimate the cost of the upgrade. We looked at the unit price, and we assessed more than 80 different components. As you can see, it's a little bit difficult here. I just took a small section of the table. You look at one, we see we have an area function that could be PCB. The unit is this need for airtight from the PCB. The requirement is to minimize contamination of the environment. The unit is drums, and the upgrade demand is 10 drums. And then there's a price associated with it. We did that for all the components, for all the scenarios. I can add here that we did not only use the 4 baseline facilities. We did that for 3 sizes of facilities, and that was 25, 50, and 100,000 LVT scrapping volume capacity. And the last 100,000 scrapping volume capacity was done in order for facility to be able to do 2 ships at the same time. I'll go further here. Well, the total cost of upgrade, as we can see from this figure, it's by far the least cost on existing pier breaking facilities. And for a 100,000 LTT facility, we estimated approximately $9.5 million US for an upgrade to a modern facility. And there's a jump up to the existing slipways to 21 million, which is not that different from establishing a facility from scratch. This is mainly due to the need for floating piers and barges for cranes on the existing slipways in order to be able to do 2 vessels at a time. The relation between the sizes of the facilities are proportional, so we basically did the different sizes in order for the facilities to recognize themselves if they have a small facility, a medium, or a large. Oh, there's a lot of small mistakes here. Sorry for that. Well, basically, you can see the distribution of the different components is mainly within yard facilities and hazardous waste handling, which is the blue part of the bar, and heavy equipment for dismantling activities, which is green. And the rest comprise less than 10%. So the majority is within these 2 areas. And that goes for all the baseline facilities. We also looked into how that can be implemented on a time horizon, and we used the time schedule, the incremental implementation schedule that Roy Watkinson presented in the case study. That is basically a short term, up to 1 year for all the minimal equipment, medium term, 1 to 3 years for simple and low cost techniques, and long term, 3 to 7 years for improved infrastructure and heavy machinery. Sorry. As we can see from this figure, the cost distribution within the incremental steps are for the existing facilities not large within the first year. The bulk of the investments are needed for the second step and the third step. It's the other way around for the basic pier and harbour, but that is basically because it's establishment of a new facility, and there's no prior operation, and a lot of basic equipment are needed in order just to begin the operation. We also did a sensitivity analysis on the key components, which was the heavy machinery and the yard infrastructure in form of concrete for the impermeable floorings. The heavy machinery is basically all the cranes and other lifting machinery and moving machinery of the dismantled part of the ships. And the scenarios we used the European market price as basis, and for the sensitivity analysis we used equipment as a low boundary. We also, for the concrete, in the basis calculations, we use mean prices based on Turkish and Asian prices, and for the sensitivity we used a low and high price as boundaries. And the concrete is basically for the impermeable flooring. It's for office and construction of office and storage buildings. As we can see, the pier breaking is by far the cheapest upgrade facility you can do. The ship from the basic installation to from the basic calculations to the low boundaries, 33% in all the baseline facilities, and between 20 to 29% more costly in the high boundary. The relation to the other facilities, the 50,000 and the 25,000 is proportional, more or less. I have a machine going on here. I hope that it's not annoying and you can hear what I'm saying. It's a little bit frustrating for me. Yeah, sorry. I hope it doesn't affect the sound.
No, it doesn't. Please go ahead.
Okay, thank you. Part of the study was also to locate feasible locations for model facility upgrades. And part of the scope was that the countries or the locations should have a history of ship import, scrapping. And what we found that some of the key parameters was that it should have an enforced regulation on environmental pollution, should be access to hazardous waste management facilities, and very importantly, there should be a strong domestic demand for steel not readily available from other sources, and low wages, and there should also be a market for ship equipment and consumables. Looking at the map, we can see that upgrade to compliant pier breaking facility, that would be feasible for facilities in India and China. For an upgrade to a compliant slipway facility, it could, for instance, be existing slipways in Mumbai, in India. And for the establishment, the baseline 3A and B, establishment of the pier breaking or slipway facility could basically be done for any port infrastructure or ship repair yard. And that could, for instance, be in the Philippines and Indonesia, which has prior ship recycling history, or Vietnam, Thailand, and of course Pakistan and Bangladesh and India. During the course of the study, we also did consultations with stakeholders, and we asked the ship owners why choose green recycling. And basically, For them, it was compliance with their own environmental policy and as a way to minimize the risk of negative publicity. An interesting aspect was that they didn't find the added costs of environmentally sound recycling as a key barrier. Some of the key challenges that they experienced was that they find it difficult to actually identify a qualified recycling yard. They also found it difficult to ascertain the consistency between what was actually promised by the recycling yard and the actual work that was undertaken. They also found it challenging when they use subcontractors in form of green cash buyers just to make sure that the transparency was there, that they could actually monitor the whole process and so forth. Part of the study was also to do a field mission. We went to China with Susan and representatives from the local Basel Convention office. And background for China is that beaching is not allowed, and they primarily use pier breaking as a shipbreaking method. It's an area which is regulated and enforced, and due to the beaching that is not allowed, it's one of the most developed with regards to environmentally sound recycling outside Western countries. We went to Shenyang Shipbreaking Yard, which has in history have several upgrade projects conducted at the yard, and they now apply key environmentally sound methods. They have procedures in place. They have largely the training, capacity building programs in place, and they wish in the future to come into consideration for the EU list of compliant facilities. And during the course of our visit, they explained that in order to do so, they would probably need to upgrade certain things, and a couple of them, one was to some of their training and capacity building courses they needed to upgrade. They needed to upgrade some of them heavy machinery and impermeable floorings for hazardous waste, hazardous material segregation. And I can see now that my time is pretty much up, and I think I'll just wrap it up here. And thank you for listening to this presentation, and can go into questions and answers.